Recording is rolling. It is Friday, January 31st. I have some Doppler puzzles for you guys. So you guys have this half page right here, front and back. Okay, so there are 8 questions over 4 scenarios. So there's so scenario 1, I got this car in motion and I got a couple of observers here, person A, person B. Right? There's also somebody inside the car. Right? So what's going to happen there? Right? Scenario 2, I have similar to scenario 1, except I got this person running towards the car. How does that change frequency? Okay. Scenario 3, I got this car rolling downhill. I'll help you guys out with this in a few minutes, right? Because there's an extra step there. Right? What's the speed of the car at the bottom so that you can find out what's the observed frequency here, right? And then scenario 4, I got rocket boosters on this car, make it go really fast. All right, hey guys, out of these 8 questions, 7 out of 8 of these, I'm looking for numerical answers. What's the observed frequency, right? So some number of hertz. But one of these questions is actually kind of a trick question. I want to see if you guys can figure out which one that is. If you just apply this Doppler effect formula, which I'm going to review with you guys too, then most of these work out fine, except there's one where the number looks kind of weird. It's like, hold on, I don't know if that quite makes sense, right? And you might catch what's going on. So I want to see if you guys can figure out what's weird about that one. So I'm looking for one of these answers, not to be a numerical answer, but write a phrase. Can you interpret what's going on and tell me what's actually going on, right? And so I turn this into the gray tray at the end of class. Most students have finished this by the end of class. If you got a couple questions left and don't quite finish it, then it's okay to turn this in on Monday. Okay, right. I gave you guys your take-home quiz yesterday. Okay, so harmonic motion waves. So that's also due Monday. Okay. Got a note here. We got an email about you guys remember past few years these resiliency lessons, right? So we weren't supposed to do this year, and then I think they changed something. So 5th period on Tuesday. So 5th period on Tuesday is going to be resiliency lessons, right? All right. So let's do some review about Doppler. Okay, so you guys remember this Doppler effect is a change in perception of the frequency from a sound source, right? Okay, so and that's all the question I'm asking here, right? What's the observed frequency, right? So observed frequency is, right? Well, if this car was parked and this observer was standing still and nobody's moving relative to each other, then wouldn't the observed frequency just be equal to the source frequency? And that would be the entire thing, right? Right? I give you all the numbers you need, obviously, right? So I gave you the speed of the car. I gave you the car horn. You guys see the car horn frequency is on here. I gave you the speed of sound. Do you guys see the speed of sound over here? Speed of sound? Right. You guys see 343 meters per second. Go ahead and use 343 meters per second for the speed of sound on this whole page, right? So if you got the numbers, you got a car horn. Now all these pages are different. I made a bunch of versions of these. Everybody has a different car horn, but you guys get the idea, right? And so car horn goes right here. Right? Speed of sound, we got 343 and 343 meters per second. Okay? Now, the critical thinking part of this is, can you navigate these plus or minus right here? Right? So let's do a review of that. So first scenario, I'm going to, now these scenarios don't all exactly match my picture, but just get the idea. Is what if the car was parked? Is that okay? Can the car be parked? And this observer is running towards the car. Because if the observer is running towards the car, does this person hear a frequency that's higher or lower than the actual car horn? Higher. Okay? And as a frequency number, so you guys, suppose the car horn was like 400 hertz. Would the observed frequency be more than 400 hertz or less than 400 hertz? How about more than, right? Maybe it's like 500, right? If he's running really fast, right? So let's say that, okay, that has something to do with the motion of the observer. So something up here, right? And how do you get a number that's more than, how is 500 more than 400? Do you add or subtract up here? If you add on top, that would make the overall fraction bigger, wouldn't it? Right? How about, what if the observer is running away from the car? So the car horn's still blaring at 400 hertz. Does this observer hear more than or less than 400 hertz? Less than. Maybe it's a really low tone. Maybe it's like 300 hertz if he's running fast, right? Well, how do you get there? Do you add or subtract on top? Subtract, right? Because velocity of the observer, right? Now, those 2 examples I just did with you guys, I had the car parked. So V source, because the car would be the source. That would just be 0, so this would just go away. Okay, is that right? All right, let's do, what if the observer is stationary? So can V observer be 0, just for a couple examples here? Right? And the car is in motion. Let's do exactly what this poster actually is showing. You guys see how the car is headed towards the observer? Now does the observer hear a high or low pitch? A high pitch. So if the car horn is 400 hertz, maybe the observer hears 500 hertz. So 400 here and 500 here. Well, how do you get 500? Should I add or subtract on the bottom? Subtract, exactly. Okay, here's why. Because if you subtract on the bottom, on the denominator, that makes the denominator small, which makes your overall fraction what? Big or small? Big. Yeah, if you divide by small numbers, that gives you a big fraction, as in more than 1, because 343 divided by 343 itself is equal to 1. So if you subtract on the bottom, ooh, now this overall fraction is more than 1. Ooh, you say 1.25 or something, okay? And finally, the last main scenario. What if the car passes the observer is now driving away? I bet it would sound like this. Yeah. Well, now he's driving away. It sounds like a low pitch. So if the actual car horn was 400 hertz, I bet the observer hears like 300 hertz. Ooh. Well, how do you get that to be small, right? Should you add or subtract on the bottom? Add. Aha. Because now that makes the denominator very big, which makes the overall fraction small, as in less than 1, right? Maybe it's like 0.8 or something, or 0.75. Okay? Right, you guys get that? All this? Okay. Help you guys out a little bit more here. The very first question says, what is someone inside the car here? Guys, if you're inside the car, would you hear the same thing if the car was parked or if the car is in motion? Yeah, because there's a pocket of air inside the car and you're moving along with that pocket of air, right? Or if you want to stick to this equation, what's 343 plus 10 divided by 343 also plus 10? This whole fraction would always be equal to what? 1, right? Because anything divided by itself is equal to 1. So the observed frequency would match the source frequency, right? Okay. Guys, good so far? Good so far? Okay. Another one I want to help you guys out with is this hill question right here. You guys see this hill? Right. So this is a complex question because there's multiple things you have to do, right? There's like a two-parter, right? So I told you the height of the hill and the car horn frequency, you have that. Speed of sound, you have that, right? And somebody's running away at the bottom, right? But a middle step to be able to answer, because the question is still, what frequency does this person observe, right? So the ultimate question is, you have to feed something into the Doppler effect formula, right? But what's the speed of the car at the bottom of the hill, right? And that's the middle step you have to chase down. If you know the height of the hill, can you figure out the speed of the car at the bottom? Okay. So I've been helping out all my classes with this today, so I'll help you guys out too. Right. Guys, what formula or what framework in physics can you use to find the speed of the car at the bottom of a hill of known height? Conservation of energy. I'd say the sum of energy at the top of the hill is equal to the sum of energy at the bottom of the hill, right? And well, sum of maybe that's it's just one energy term in each part. Is what type of energy at the top of the hill? Potential energy. And what's the formula for that? MGH, right? What type of energy at the bottom of the hill? Aha, kinetic, which is 1/2 mv squared. There you go. And what are you solving for again? What are you solving for? Yeah, speed of the car. This velocity, right? Speed right here, right? Right. Oh, I never told you the mass of the car. Wait, is that okay? Aha. Yeah, mass of the car goes away. Okay. Can you guys solve for V? Heck, how many guys are looking at it saying, that looks a lot like the Galileo question all over again, doesn't it? Which you guys have seen a bunch of times. Yeah, let me get this phone call. Pause this. All right, back here. So can you guys cross multiply the 2, take the square root? It's the same thing as Galileo question in disguise, isn't it? Drops the ball off the tower, how fast to go to the bottom, right? Now, that's not the final answer to this question because that's just, you'd be solving for a speed. And the question is what's frequency. So once you have the speed, you guys see that you could go back to this Doppler formula and figure out from there. Okay. All right. Any questions so far? You guys all right? All right. So go back to the beginning, remind you a couple of things. Okay. One is, I bet you guys will probably finish this by the end of class, but if you don't, you can turn it in Monday. That's all right. Right. Along with your quiz, which is also due Monday. Right. And remember also, there are 8 boxes. Only some of them actually have numerical answers. One of these is sort of a trick question. And when you get there, I think, like if you just kind of blind plug everything in your calculator, I think you'll see something weird. So kind of flag it anyway. Right. And let's see if you guys can figure out what's weird about it and write out a statement what's actually going on. All right. So we're gonna walk around, help you guys out, and you guys can help each other out. Turn that in the class.